Welcome back for another 7 Caillou challenge. Wishing you a very Merry Christmas today, and glad to have you here doing a challenge with me if you were able to break away from the family for a little bit. I'm going to go ahead and read the description to you because it confused me a little bit at first what they were going for, but it's not too bad. Basically, they give you, you're probably familiar with this famous Christmas song, you know, on the 12th day of Christmas, my true love gave to me 12 drummers drumming. You know, it goes through all the numbers and you kind of keep repeating it. So that's sort of the content here. The task, you have to write a comparator function which can sort the lines back into their correct order. So all we have to do is implement the compare, and if you look through the tests, you're going to find that they do, let me expand this, they're going to handle populating the correct lyrics here. They'll go to the trouble of shuffling those for us. You see, they implement this all. We don't have to worry about any of this. And then they sort of, once they're shuffled, they call sort using our comparer here. And if we do our job right, it'll get back to the original. So that's sort of, we just have to implement a comparer. And if you don't know what that is, we're going to look at that, so don't worry. Maybe you want to watch that before you pause. If you are familiar with that and want to just go for it, go ahead. But yeah, that's the task at hand, is that we're doing this Help Save Christmas, which is basically restoring the lyrics after they've been shuffled in any manner. So I'm going to shrink this. A lot of times too, if you're confused about what they want, I find it very helpful to scroll through the sample tests and see, you know, what they kind of instantiate down here and what they test against. And it can answer some questions that aren't resolved in the description text. So anyways, I think that's clear. We'll go ahead and get into this idea. You can see this Help Save Christmas class that we're in implements, right? It's got a colon after it, means it implements this IComparer interface. And I know right away this is an interface because it has this letter I prefix, capital I. When you see that in C# with classes, it's a nice little cue that you're dealing with an interface as opposed to a normal class. And so if you want to pull up the document page for IComparer, you'll see they call it an interface. There's lots of others. You see these iDictionary. We of course have dealt with iEnumerable, etc. That's just your indication that it's an interface. Interfaces, they're not like classes. We don't instantiate them. They more define that a form that a class takes. So when you implement an interface, it means that your class can be viewed as that type by an outsider. They don't need to know or be concerned about anything else your class does. Your class, you know, it should be small and not doing a ton of things, but in theory it could do 1,000 other things. And the nice thing about an interface is that you don't have to care about any of that. You just have one concern about it. So think, for example, like think about a car, right? What's the interface to a car? Well, it's simply put the steering wheel. You've got an accelerator and a brake pedal, right? As long as you have that, that's sort of the human interface, right? Any human can operate your vehicle, and it doesn't matter. Your car could be very basic and simple, or it could be the most fancy luxury car in the world that had 1,000,000 features. As long as we just need to know that it's a car, right? We expect a car to have an accelerator, a brake, a steering wheel. You know, I know in modern times we expect radios and other controls, but bear with me for this example. All we care about as the driver, someone who has to drive the car, is that it has those 3 objects that we can use to pilot it and get around where we need to. All the other stuff's gravy. We don't need to know anything about the advanced features or what other concerns there are with the car besides driving it, you know, like what it represents or anything else. You just care that it's a car. It has that interface, and so you can use it like a car. You may also use it for photo shoots or anything else, but from the point of concern with for using the car. That's sort of what the interface gives you. And so feel free to read this description here. Exposes a method that compares two objects. So that's the big thing with these comparers, is that they have to implement this compare method. And that's the rule. When you inherit from an interface like we've done here, the colon indicates that, right? We've seen inheritance too, where you can just put a class name afterwards, and that means that your subclass is a type of the class. It has all those properties of the class plus whatever else you define for it. This is different. This is saying it implements an interface, meaning you have to go to that interface, you have to look at its methods, we expanded methods, and it has a compare method. And every method listed you have to implement if you want to be a valid implementation of that interface. Luckily there's only one here, so we're going to do this compare method, and I think that's stubbed out for us, right? Yeah, so they got it ready for us. We have to do this, otherwise you're going to get errors. If it's going to say, hey, you are not an IComparer if you can't compare two objects of the type you are, you know, in this case string. So good. Let's read about that. We're in compare. The compare method compares two objects and returns a value indicating whether one is less than, equal to, or greater than the other. And you do that with your return type. Notice it returns an int. You're going to have two objects of the same type. Well, they'll be strings in our case. And if they're equal, you return 0, meaning they're the same. And then you can return 1 or -1. Those are the values I use. It looks like generally you can use any values you want. If less than 0, x is less than y. So I guess you could return -27 and +42, or whatever you want. I keep it simple. I just use -1 and +1. I'd recommend that. So that's how you indicate the relative ordering of things. If less than 0, meaning -1, it means that x should be sorted before y. It's less than y, so it should occur in front of it. And so if you remember in the tests, where was it? They shuffled, they sorted. So we've seen arrays sorted before where you don't pass any arguments, right? And you can do that with these built-in types like integers and strings, and they have their built-in behavior. If you do it with integers, they just arrange them in ascending order. If you do it with string, it should be alphabetical order. But if you ever go to look at sort's implementation, there should be an overload that allows you to specify a comparer. And those are really nice because you don't always want just the default behavior. Sometimes you run into cases where you want a custom sorting behavior. And that's really powerful and flexible here. So you will eventually come to really appreciate this. And so we have help save Christmas, and the lyrics were over here again. So we need to make it happen in this order. Now, the way that just popped into my head about doing this was that we're sort of sorting, and I noticed that, look at this, most of these lines, almost all of them, start with a number, right? And so I thought, well, what if I just grab this first word in each string and sort of parse the integer value from it, and I can compare those values to determine what order the sentences should be, the whole sentence, right? I don't care about any of the words after. I get a nice clue right here. And then the exception, of course, is these first and end lines where they don't actually have a number. So I'll handle those cases specially. But for most of them, I can get away with just grabbing this number and using that for the sort. So again, if you haven't paused and tried on your own, you should do that. I think I gave you enough information to be well on your way. And then otherwise I'll get into it here. Just fixing the indentation there. Okay, so we are going to compare this in the manner that I just described. Now what I want to do then is, for my algorithm, I'm going to convert the strings into a bunch of tokens, right? They're separated by white space, and I can say string, let's call it tokens1, and I'm going to say, I'm sorry, this should be an array because we're going to use string split. If you don't remember that, you can look up the split command. That's, all strings can do it. You give it a character you want to split by. I'm splitting by a single space. And so, you know, imagine when I call this on this first line, I'm going to get an array filled with on at element 0, the at element 1, 12th at element 2, day at element 3, etc. And so I'll do the exact same thing with line 2. Call this one tokens 2. It'll do the same thing with all these lines though. And like I said, I'm going for that first word, and I'm going to use that to make my determination, to sort of do a comparison. And so, yeah, let's do that. I'll say it's going to be something like this. Let's just do this by the numbers, then we can clean it up later. If tokens 1, 0, right, at element 0, that means just the first word, because that's the one I care about. I don't care about the rest of the sentence. If that equals on, right, you can see I need numbers for these ones that don't have numbers. So hopefully it's clear that this one on should be 13, represents 13, and right, that's kind of in pattern with the numbers here, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. And you may have guessed I'm going to call this one 1 if it starts with the letter A. So let me make some local variables to hold these values. I could say int val1 and val2. And so if that's the case, I'll say val1 equals 13. And I'll say else if tokens 1, 0 equals A, val1 equals 1. Oh, don't forget my semicolon. And then else val1 equals int32 parse. This is where you can convert a string to an integer. And I'll say tokens 1, 0. Right? So we handled the couple oddball cases. Otherwise, we can just assume that first word is going to be a number. Obviously, I'm missing input validation here. I'm relying on the challenge. The challenge doesn't violate this, but in real life, you might want some error checking here. Maybe you can't count on the letters being capitalized the way that you expect them to. Even if you don't do that, you should be thinking about it. I want to get your brains thinking like that. And I'm not going to do the prettiest thing here, but you can imagine we'll clean this up. Like I said, don't worry. I'm trying to show you step by step. This is a common thing beginners do too. They copy code, you know, and then you just basically do the exact same thing. But this is a smell, and we're going to fix it. When you see code repeated like this, it should be an indicator to you, like, hey, maybe I need a method to handle this, and then I can just call that. But anyways, you can see we need to do the same thing for our other line, right? Because we're going to get 2 lines. When you call that sort command, it's under the hood calling this comparer, because we passed that in the overload. Remember, I showed you that in the sample tests down here. So you don't see it being called, but this sort is using your comparer to sort the elements. And so it's going to call this a bunch of times. You could put print statements in here if you want to see how many times it's going to be called, and it's going to get all these results and use that information to get the ordering you want. So good. We got values for everything now. So now we're left with that task of, you know, check the 2 and return 1, 0, or -1. So you could do something like this. You could say if val1 is less than val2, they told us if val1 is less than val2, return 1. And then we could say if val1 is greater than val2, return -1, else just return 0. That means val1 and val2 are equal, just return 0. And so I think that's enough, because that's essentially what we had to do. Remember from the compare method, it said If x is less than 0, it means x is less than y. So we had if x is less than 0, that was this case. Hold on, let me go back. If less than 0, x is less than y. If greater than 0, x is greater than y. So we got that implemented. We want it kind of marching down, right? We're doing a reverse ordering there, right? We're kind of going 13, 12, 11, 10, 9, 8 because of the way they printed these lyrics out, right? So that's kind of why we have the inverted logic here. So I'll go ahead and give this a test. Good. Attempt. Good. Nailed it. And so if you had print statements, you could check that out. They print some information for you there. I'm going to go ahead and take a chance to clean some of this up. Some of those, like this, the smell I told you. Let's make a method to do that. Make it private because nobody else needs to know about it. Static int, let's call it get val from text, and take a word in. And then basically we can just take this whole logic here and it's not tokens 1 anymore, right? It's word. So we've got to update that. And if you have an IDE that you're working out of, they have tools to make this refactoring kind of thing really easy. So yeah, actually this changes a little bit. We would say, we're not assigning, we're saying return 13. If that, then return 1. You don't need the else's, right, on returns. And then otherwise return this. Okay, that looks better. And then once we do this now, you can say tokens 1, 0 and val2 equals tokens 2, 0, right? And now you can blow this whole thing away right here. I already took 1. But see, that makes it a lot more compact. You're not copying yourself, rewriting the same code over and over, bloating everything. So I definitely think that's a good improvement. And then I don't think this part's bad, but if you wanted to make it into a compound sort of ternary expression, you could say, let's comment this part out. You could say return, and we could check if val is less than 1. Val1, I'm sorry, is less than val2, question mark. If that's true, we saw that we returned 1, right? Otherwise, we've got 2 other conditions, right? So I'm kind of chaining these. I'm going to put another ternary in here. And if you think this is confusing and not readable, by all means, you can leave it the way it was. But you could also say val1 greater than val2, colon, in that case it was -1, else 0. And so you kind of have this compound statement. I don't think it's terrible. I wouldn't argue with anybody who said you shouldn't chain those together, so I'll leave that at your discretion, whether you think that's appropriate or not. Let me make sure I typed it right. Let's hit the attempt again. Invalid expression on line 12. Let me see what I did. Oh, yep, I didn't need a colon there. A little too much colon. It's not like cowbell, right? Okay, so we hit the green. I'll leave it. It's fine. People seem to like really compact answers on here. Okay, so let's see. Yeah, that takes it. Nothing else to take out. With the if-else kind of way I did it before, if you were doing print statements, that could have been nice. Let me, before I sign off, let's do this. Right line, $, we'll say val1, val1, and let's add line 1, line 1. You can see the val associated with it, and then you can see line 2, and you can see the val associated with val 2. If you want to see this thing in action, how it kind of steps through, you can. Example. So this is they print this jumbled bit, but you can see line 1 was 10 lords a leaping, and from that it extracted 10, which is what I wanted, right? 10. I didn't care about the lords a leaping. And line 2 was 2 turtle doves, and I got 2. And you can see on this one of the oddball cases, it started with on the 12th day of Christmas. On was associated with value 13. Perfect. So yeah, I'm going to take that out, but I'm just showing you that if you want to see how when you call sort, it runs all these comparisons that it needs to shuffle the elements around and sort them into their right location. If you want to see that, you can always just add those sort of lines. So maybe interfaces were new to you. Hopefully the car example was good. I mean, if you think about it, we use interfaces all the time in real life. Imagine something like USB, right? Manufacturers that make devices that hook up to your computer, as long as they implement the USB interface, right, they're good. People that make computers don't know how third-party vendors after the fact are going to make devices, right? And even if they wanted to or could, you can imagine how much work it'd be to try to write software to communicate to every possible device that could ever be invented. So to get rid of that madness, they say, no, hey, look, we're going to make this protocol USB. When you guys make your devices, make it compatible with this, and then we can talk and we can speak the same language and get done what we have to get done. And if you're the person making the computers or the OS, you don't need to know anything about some microphone that connects to a computer. You don't need to know anything about microphones or any electronic device that connects to your computer. So that's kind of, you deal with interfaces all the time in your life. Imagine if you worked at some theater and you were kind of in charge, you're some kind of manager working on making the audience happy, and imagine you have some department there that deals with sound, and they're the experts. They know all about speaker systems and audio systems. You don't have to know anything about that, but to get your job done and make customers happy, you need the audio to come in when it's supposed to come in. So like if you guys have some kind of interface where you can just say play audio, stop audio, you don't really care, are they using the latest technology or what kind of speakers, or is it going to a headphones? It doesn't matter. You agree on this interface, play audio, stop audio, that you can just call it. You don't have to know anything about the audio. You didn't go to school for that. You don't need to know. And so that makes it where people from different departments can interface well, and everybody can get their job done and not have to know everything about everything, because you can't. So interfaces are really good. They're very handy. Hopefully one of those examples resonated with you, maybe the car one, but I'm trying to make that clear. I'm going to go ahead and submit after I got this cleaned up. Collect those points. They're going to make me run again here. Still green. Go ahead and submit. Get some Caillou points for Christmas too, right? Hopefully you got something cool. Let me know if you got something good for Christmas this year. and go ahead and check out other people's answers. See what you can learn from them too. Good stuff. Otherwise, hit me up with your questions and comments, or I'll see you in another video. Again, Merry Christmas. See you soon.